Question number 38. Which of the following statements is or are correct regarding the Daniell cell when it operates at room temperature? Net electron flow occurs from zinc to copper. That is true. Because zinc is the anode, copper is the cathode. How do we know that? You should remember at least the activity series or the electrochemical series. Now in the electrochemical series or the activity series, zinc positioned in a higher position than copper. So if a higher position electrode is present, it is the anode. The lower position electrode is the cathode. So zinc is the anode, copper is the cathode. So what happens when the cell operates? Zinc goes to zinc 2 plus. That means electrons are released from the anode here. Therefore anode will be the negative end, cathode will be the positive end. Copper 2 plus accept those 2 electrons to form copper solid. So the cell reaction will be zinc plus copper 2 plus gives zinc 2 plus and copper. Now the arrow should be like this, it shouldn't be like this. Zinc 2 plus. Now the difference is this is written when the cell is operational. When the cell operates. Now this is when the cell is not operational. Not operational. When the cell is operational, this equilibrium drives to the right. Therefore, this is the correct one for the question that we are considering here. Therefore, first statement is correct because net electron flow occurs from zinc to copper. See, zinc gives the electron, copper accepts the electron, so the electron flow goes from zinc to copper. The equilibrium zinc plus 2 electron shift to the right. No, it's wrong. Actually, it says the backward reaction takes place here. It is not. The zinc 2 plus is not forming zinc. It's the other way around. Zinc forms a zinc 2 plus. Therefore, statement B is incorrect. C statement, a liquid junction potential is created due to the presence of a salt bridge. This is wrong because when we draw the cell here, let's say this is our copper electrode, and it is inside the zinc electrode. Now this is zinc electrode. So we can connect these 2 electrodes via an external circuit. We can put a voltmeter here. Now this is a operating cell. Let's label them. This is copper. This is copper 2 plus. This is zinc. This is zinc 2 plus. Now this is a galvanic cell which shows a liquid junction. Now if this wall of the container which contains copper electrode is formed with a porous wall, you can use cardboard for that. The 2 electrolyte, the copper solution and the zinc solutions are the 2 electrolyte. They are connected through a liquid junction. This is called a liquid junction. Now when the cell operates, you can see that zinc ions are concentrating in the solution here. Copper ions are getting decreased inside here. Therefore, a liquid junction potential. So there will be a higher positive potential generated here, less positive potential generated here. So there is a potential difference between the wall of the container of the copper electrode. Therefore, a liquid junction potential is created when the cell operates like this. So to prevent the liquid junction potential, we can do a thing like this. Let's copy that, paste here. We can take out the copper electrode from the solution. So there's no liquid junction there. This liquid junction disappears. Now what happens? Then when we try to connect these two, the circuit is not complete. So we have to connect the two electrolytes. Let's label them first. Copper here, copper 2 plus here. Now the copper electrode is out of the zinc electrode, so there's no liquid junction potential, but the circuit is not complete. Therefore we have to connect the two electrolytes using a salt bridge. Let's put a salt bridge like this. This is the salt bridge. Now when the cell operates, zinc ions are concentrated in here, but the negative ions inside the salt bridge will come in this direction. The negative ones will come this direction and neutralize the positive potential generated in the zinc electrode. So this will be cancelled. Now there's a less positive potential in the copper electrode will be generated. That means the negative ion concentrations are getting increased. Therefore positive ions from the salt bridge will come this direction and will neutralize the negative potential generated in the copper electrode. So therefore a liquid junction potential is not created in the presence of a salt bridge. So the function of the salt bridge is to neutralize, or we can say is to keep the electroneutrality in anode and cathode regions, anodic and cathodic regions. By preventing a liquid junction potential. Alright, so you can understand what's the difference between a salt bridge and a liquid junction. Therefore, the C statement is incorrect, because a liquid junction potential is not created in the presence of a salt bridge. Statement D, the equilibrium copper 2 plus 2 electrons goes to copper shifts to the right. Yes, we can see that copper 2 plus become copper plus when the cell operates. So that statement is a correct one. So our answer will be A and D, which means the answer is the fourth one. Okay, let's move on to the next question.